So in AP Lang we have statements, right? So these statements can be made into truth tables through discrete math. So let's take the variable p, right? Let's say it means going to school on Friday, right? So p means going to school on Friday, and let's say q means got a job. You get a job. So these things are somewhat unrelated statements, and as a result, you can draw truth tables, or rather, in math, you can draw truth tables for every single statement. So if it's true that I go to school on Friday, it could also be true I got a job. Likewise, I could go to school and I could not get a job, which is what normally happens. It's also possible I don't go to school and I get a job, or I don't get a job and I don't go to school. So if a teacher tells me that if I go to school on Friday, I'll get a job, this can be denoted by P leads to Q. Oftentimes it can be read like if this, then that. So if I go to school on Friday, then I get a job. And from there, you have to look at this through these two statements. So P is true. That means I go to school on Friday. And since this is true, then and Q is true, that means this statement is true. Likewise, if I go to school on Friday, and my boss tells me that, or teacher tells me that if I go to school, I'll get a job, and I don't get a job, that means this statement is false, and well, he's lying. Now, let's say I don't go to school on Friday. What would happen? You would think that this statement is false, right? Because I didn't go to school. But the statement will always be true because of the fact that because I didn't go to school, this condition has never been fulfilled, and therefore you can't make any assumptions if the first condition isn't fulfilled. So therefore the statement is always true, or any if-then statement is true if the if condition never happens. And now we go into a valid argument. So valid arguments have true premises and true conclusions. So since this is a premise, and this is a premise, right? So the premise is that I go to school, and this premise is that going to school will get me a job. We look at when the premises are true, and there are only two instances where this happens. This line, where the P is true, and the statement is true, which means the conclusion, which is the Q, is also true. As you can see, all these three are true, so therefore this is a valid argument, because the premises are true and the conclusion is true. Done.
So what we have here are the operators that we use in discrete math. First one is an OR operator, and basically true if either P or Q or both are true, or both statements in this case. So we have P or Q. If either P or Q or both of them are true, then it follows that that statement is true. We have next an AND operator, which both of them need to be true. So if we have P and Q, both P and Q need to be true. Otherwise, the statement is false. The next one is a tilde, which is essentially a not. It negates the statement. So if we take P to be true, then tilde P is false. The next one is an if-then statement. So basically, one statement leads to another. So if P, then Q, and then for the last one we have an if and only if. So P, if and only if P, then Q, and in this case both values need to be the same for both P and Q. We'll do the AND table now. So we take the same arguments again, A, B, A, and B. Then we'll do the same truth table again. So we have to start off by filling in the A column, true, true, false, false, true, false, true, false. And then over here, both the values need to be true. So A and B are true, so that's true. A is true, but B is false, so that will be false. A is false this time, and B is true. One of them is false, so it's false. Remember, since both of them are false, the conclusion is false as well. So a lot of you might be wondering how this relates to arguing and argumentation. And so we have here two statements. P, today is a Wednesday, and Q, today is a minimum day. So if you remember from before, the implication operator, then we can use P leads to Q, or in which case reads as, if today is a Wednesday, then today is a minimum day. And also, in language, there are statements known as contrapositive statements. So, in a contrapositive statement represented in discrete math is tilde q leads to tilde p in the event that p leads to q. So, if we take this statement first and flip it around like this, we take it such that if today is not a minimum day, then today is not a Wednesday. And that, for example, is one way we can use discrete math and flipping around statements in language. We have other applications to this as well. For example, converse statements, where we can use P leads to Q, and again, same argument as before. Today is a Wednesday, then today is a minimum day. Can now flip it around with the converse statement, which is Q leads to P. In which case, if today is a minimum day, then today is a Wednesday. We also have inverse statements, which occur when tilde P leads to tilde Q, or in this case, if today is not a Wednesday, then today is not a minimum day. And again, this is very similar to the contrapositive statements that I mentioned before, but slightly different because we didn't flip around the tilde p and the tilde q. They're both in the same location that they started off in, and we can use discrete math to sort of highlight the way in which we flip the different statements around in the argument. So the last main application we'll go over is modus ponens, and the way modus ponens works is it's sort of like a proof. We can first state the conditional. So if P leads to Q, so if today is a Wednesday, then today is a minimum day. So then after that, we state the first part of the conditional P, then we can conclude therefore Q. So it basically follows that if today is a Wednesday, then today is a minimum day. Today is a Wednesday, therefore today is a minimum day. Again, that's the way we want to structure arguments because they sound fundamentally sound. We have, I guess you could say, two premises over here in 1 and 2, and then we have a conclusion over here, and that's what makes a complete argument, and it's completely valid as well.